wonderful introduction, so I won't go into this further. We're introducing a scale that we're working on developing right now, but I do have to give a shout out to my wonderful research assistants, 3 of whom were in the room, Chris Donovan, and Emma Cripps, and Sadie Block, and Cecilia Boyson has also been, to make sure, have been helping me develop the scale over the past year and a half or so. So let's talk about.
No, it worked before.
No. Okay. Let's talk about electroscopes. Okay, so this is going to seem like a little bit of a diversion, but trust me, just bear with me for a second. So we're going to go all the way back to year 1600, when apparently it was actually Queen Elizabeth I's physician who developed this little device called the visorium. And what it does is it detects the presence of an electrical charge. The whole thing spins around. There's an electrical charge. It moves around. There's not. It doesn't. Okay, cool, right? Now later we see like further development of this measurement, where you get the gold leaf electroscope, which is more sensitive, is able to like detect some more magnitude, and is able to do a little bit further development of the science. Now, take it another 100 years, and you get this lovely device, which was actually developed by Marie Curie's husband. And it takes this ability to say, here we're just like spinning when the presence or absence of electrical signal. Here it takes it to a whole different level, of precision. And this ability to precisely measure what's going on with this electrical detection allows Marie Curie to detect radioactivity for the first time and revolutionize physics and chemistry with still the only one who's won two Nobel Prizes in different fields. Now, if she were still working with this little visorium, there's no way she would be able to have developed that science, and all of these new insights would have been impossible. Now, let's look at social science. So here, electroscopes have been going on for quite a long time. Same thing, a lot of the hard scientists. I trained as an ecologist in undergrad, and all sorts of little devices, very handy things. Now, in social science, we start in 1865 with the first development of like a sampling method. There's case study methods and like sampling methodologies for surveys. That's not that long ago. It's like first time we're using surveys. 1932, just 90 years ago, Likert comes along and starts to provide these scales that have, it's not exactly a linear measure, but you can rate on a scale of 1 to 7 or 1 to 10. And then in 1960, and around that time, we have the Rasch model developed. And this is where item response theory start to come up, and we get a little bit more sophisticated. Now, why do I say this? Is that a lot of the behavioral science of environmental behavior, like a lot of how we study environmental behavior, is still around. I would say maybe like right here. Like we're working with maybe a gold leaf electroscope when we're trying to figure out what exactly are people doing, how are they doing it, and can we detect the level of precision and change in order to really advance the science and understand how these nuances work together to develop motivation for pro-environmental behavior. So what I'm trying to do with this work is just bring it, I don't know if we're going to get here exactly, but we're going to try to advance the tool of measurement so we can have some chance to detect change over time in pro-environmental behavior. And I will have to say, I have to give a shout out to a failed proposal. If anyone was on my Hatch grant proposal, evaluated by natural scientists, they didn't like my measurement. They thought my measurement was crap. They rejected the proposal, and I was like, look, guys, like we don't have these devices. Like you measure, you study plants and dirt, and like you can put a little probe in there and it gives you the science. Like I don't have that. It's not my fault. Sorry, that's what we got. You work with what you have. But it really got me thinking about how we could do better. So this launched this new work on developing what we are now calling the REBL scale, because why not? So right now, measurement of pro-environmental behavior is mostly, well, it's just probably a little bit of a mess. We have a lot of ad hoc measures. We just have like a one-off, like, did you install solar panels? Like, are you going to do this one little nudge that we're trying to get you guys to do? Like, a lot of these measures are ad hoc, and there are some scales. Some of these, this has got, almost 2,300 citations, so it is pretty widely used. And there are various versions here. This one is also using the Rasch model, which is what actually got me turned on to the Rasch model in the first place. It was like, this scale actually follows more of the measurement theory. It has like really strong properties, psychometric properties, that this whole idea of just throwing a bunch of Likert questions and then averaging them over a bunch of people, like, doesn't quite cut it. So this takes it to another level. But the problem with all of these is that these are poor measures of behavioral change. So if we want to be able to measure change, we have to have a measurement that can change over time, over a short period of time. A lot of what I do is randomized controlled experiments where I will, provide an intervention, randomize an intervention, and then measure the outcome. And we want to see how it affects behavior. And this is, widely practiced in environmental behavior. A lot of times we can measure intentions. And if you ask people about their intentions will change. But then you try to actually measure target behaviors, and it's really, it's kind of a crapshoot, basically, in terms of whether or not you're going to get the right target behavior. There's a lot of noise, there's a lot of barriers, there's a lot of reasons why, even if your pro-environmental motivation might have been affected by an intervention, you're not going to see that response in the behavior because the tools you're using to measure are just not up to the task. So we're looking to create this new tool that can be used in both experimental studies where the ideal format would be in week 1, we ask about your past week behavior. We give an intervention at week 1, and then a week later we follow up and say, how was your past behavior since this intervention? And we see if we can detect differences between treatments. It can also measure things like the impact of policies. It can measure things like the impact of extreme weather, which is another thing that we're working on and that my research assistant, Chris, will be continuing to work on as well. So if we want to understand all these different dynamics and the complex aspects of motivation that go into environmental behavior, we gotta have something that can that can measure change. So I just scoop myself here, but this is a nicer slide to say it. So if we want to know how it changes, we got to measure change. Simple as that. So what are we going to do? Our measurement target with the REBL scale is the latent driver of behavior. Basically, if you're an economist, you might call it dynamic preferences for pro-environmental behavior. What causes you to choose the pro-environmental action over the less environmentally friendly action, or normal people would call it pro-environmental motivation. Now, you can think throughout your day, you're making all sorts of decisions that affect the environment, which can get a little stressful if you think about it too much. But like, I carry my reusable water bottle with me. I try to bring my bags to the store. On any given week, maybe I'm real busy and I just forget and I didn't bring my bags and I don't do the things and I'm taking shortcuts. My motivation is not my top priority. It's dipping below where it might normally be. That's something we could detect. Or perhaps I just was endlessly inspired by a David Attenborough documentary, and now I'm really thinking about everything I'm doing in my life and trying to do pro-environmental action. We should be able to detect that as well. So what this measure does is, if you think about the overall, we're looking for this latent driver of behavior. And since that behavior is so diffuse, we have to have a lot of different questions to measure different pieces. Who knows which decision you're going to make on how to be more pro-environmental this week. So we have different items. Items are basically questions. And when we spent a lot of time, as my research assistants will attest, developing a bunch of different potential items. The real criteria for items is, first of all, it has to be something that is driven by preferences for pro-environmental behavior. It can be driven by other things too, but that has to be pretty fundamental. It has to be behaviors that occur frequently. So if I ask you if you have solar panels one week, if I follow up on it next week, chances are you still don't have solar panels. And it needs to be pretty low barrier behaviors that have the potential to change. So something that you could do one week and not the next week. Although these barriers differ depending on where you live and how much money you have and what kind of life you're leading. So we are going to pay a lot of attention to how those barriers affect these behaviors and affect. And I also just defended her master's or her undergraduate thesis, looking at that very thing. So you can ask her all about it. We chose to use yes or no questions. Now, I know we're ignoring Likert. We've been around for 9 years. I often use Likert scales. And the decision to do this, is one that's driven by really 2 things. One is that if you look at a Likert scale, if you say, do I never do this, I sometimes do this, most of the time I do this, occasionally I do this, all of the time, like my sometimes might be a little different than Sadie's sometimes, like these they're a little bit squishy. Whereas yes or no is a clear line. So that allows us to have an added level of precision, even though, we allow it, okay, let's just leave it at that. It allows for a little more precision. And the other thing is that when you're answering a survey, if I'm going to ask you 50 questions, you want to do it real fast. So if I'm asking you a question that's yes or no, it's much faster to answer. It's less cognitively intense. And so if I ask, here's an example question, in the past week, have you carried a reusable water bottle with you? Yes, I have. Hydration there. Okay, so we've collected data in 2 rounds. The first we did last summer. We had 500 participants, and we started with 112 initial items, like a big survey. Now, I will say that we're not planning to give 100 items to each survey, like in future iterations. We want to condense that scale down to a reasonable number. Now, what's the reasonable number? There's trade-offs. My plan is to try to get like to 20 to 25 would be the smaller version. And then if you want more precision, then you could have a scale that collects maybe more like 50 items. But depending on the researcher's goals and depending on the constraints on the particular study, you're going to be trading off precision for a number of questions. And for both of these, we recruited nationally representative samples online using Prolific Academic. And between these 2, we did a lot of work from July to April. We modified a lot of questions. Some of them seemed a little unclear, there was confusion. We dropped questions that weren't working at all. And then we added items based on this initial Rasch model analysis to try to fill in certain gaps and get in areas that we hadn't addressed before. We also collect a bunch of other variables. We have environmental identity, efficacy of pro-environmental behavior, other like climate change belief, green, warm, glow, which is a really fun thing, and I could give a different talk on that on a different paper, but demographic variables, and importantly things like urban, rural, suburban, because that's, if I ask about public transportation, that's a huge barrier if you live in a rural area, not a huge barrier if you live in an urban area. And so we use these to test construct validity and invariance. Invariance means like, I don't want to penalize you just because you live in rural Vermont and say like, you're not environmentally friendly because you didn't take the bus. Well, that's hardly fair. We want to have a scale ideally that's going to be similar for different groups of people. Because, if I take my thermometer and measure the temperature in one city, and then if I go off into a different part of the world and measure temperature, I need that measure to be invariant. Otherwise, you really can't compare across different studies, and it makes it difficult to then go through the process of building a solid foundation of understanding of these behaviors. And that happens study after study, collectively over time. So let's talk about the Rasch model. This is a really clever model. Basically what it does is it models the probability of doing a pro-environmental behavior. And it's a function of both the item difficulty, like how hard is it, and the REBL score, which is the individual preference or motivation. And this Rasch model actually comes from the education field, where they're using tests to understand students' ability or understanding. So if you have, your students at the very top of the class are only missing a couple of questions, the questions that they're missing, chances are those are like the really hard questions. The people at the bottom of the class are missing a lot of questions, and the ones that they are getting are usually the easier questions, but not always, because there allows for some noise and a probability of actually having a correct response. And importantly, the Rasch model transforms all these binary observations into an interval measure. Now, I'm not going to get too far into the interval versus nominal versus ordinal, but if you ever run a regression, we say like, okay, we need it needs to be a interval scale, like the interval is a number line, right? And then if we have like group measures, we're kind of like, it's close enough. But some argue that there are problems with those scales, although I still do it, so I'm not going to dog it too much. But ideally, the interval measure is going to give you better results and better, more valid statistics. So the Rasch model uses conditional maximum likelihood to take these binary observations and solve for these person parameters. So each person who takes our survey is going to be assigned a REBL score based on how many behaviors they say, yes, I did this behavior, where like, we use the yes, or the, we make it so we have some flipped behaviors, of course, but the pro-environmental thing is going to be increasing your REBL score, and then the item difficulty. So some items are very difficult. Any vegans in the room will be happy to hear that vegan is at the very top of the list. And at the bottom of the list is if you can refrain from posting like misinformation or like mean things on social media about how like environmental policy is terrible, then you're at least going to get like that minimum score. So it's not that hard to not be an online troll. So here's our very first initial distribution, and what this gives you. I know the graphs are going to get a little wild here, but so what you're looking at here is this histogram. So this is a histogram of your REBL score, and then here is the item difficulties. So this is like a whole bunch of items, 111 items, and each one is like all these different difficulties. So we see, I think this is probably your don't post mean stuff on the internet about environmental behavior. And then over here, I think actually this is a clothing swap, which is very environmentally friendly thing. You should all try it. It's just a clothing swap, but it is something that doesn't happen very often, so it's not an ideal question. So here is another way of looking at it, which is both very pretty and a little bit crazy. But basically, what these graphs do, these item characteristics curves say, at any given dimension, if I'm like really not so environmental over here, this is my probability of not posting something anti-environmental on Facebook. I still, even if I'm like pretty curmudgeon-y non-environmentalist, I still have like say, where was my 50% chance of having not done that behavior. I'm sure he's like environmental. But this basically, the range here shows kind of like the coverage. How well are we covering the whole spectrum of environmental behavior? So we have the easy stuff here, the really hard stuff here, and all the kind of medium stuff in the middle. So we see really dense coverage of the moderate difficulty stuff. And then we find like these things are really probably too hard, even if our most pro-environmental people are not actually doing them. So our beta 2, we changed, so this starts with 111 items. Our second set of items is 89 items. And we see a little bit better behavior, although we see a lot of overlapping in the middle, which tells us like we can cull a lot of these items, and how we'll cull them is the complex question, because you're trading off different scale characteristics. Now this mess, the next one's better, but what this tells you, one of the first things that you need to do is to just determine, does this item fit? Does this item fit with this underlying latent drive for pro-environmental behavior? And so if something is in between these two lines, that means that it's like statistically it's fitting pretty well. You're showing that like people who are super environmentalists are most likely to do all of these things or have like the highest probability. People who are like lowest environmentalists are most likely to do these things. And then things like drinking cow's milk. Like we know, and despite being in Vermont, we love the dairy industry, cow's milk does have a stronger environmental impact than other types of like milk alternatives. But people, they're basically what this is saying, because it's like way off in the side here, saying like, well, people are not just deciding not to drink milk because they want to be an environmentalist. Maybe they're lactose intolerant, maybe they just don't like milk. And that makes that a bad item because it's not aligning with, it's measuring something other than this like pro-environmental motivation. So here we get a nice cleaner version. This is a reduced set of items. We got down to 24. And I will say this is not going to be the final set because it behaves pretty well on some characteristics, but we're not done yet in terms of optimizing the various aspects. And hopefully, should I be able to get through some bureaucratic hurdles with UVM, I will be collecting another round of data next week, because we want to see not only does the scale behave in a single shot survey, but we also want to see, like, if I ask you this week how you're doing on these various behaviors, and if I ask you again next week, if nothing's happened in between those, like I didn't give you an intervention, I didn't try to like convince you to be a super environmentalist with all of my clever experiments, like you shouldn't see a big change. So if we see people jumping from being mediocre environmentalists in 1 week and then super environmentalists in the next week, that tells us that the items that we're asking about are too variable. And on the flip side, you want to make sure that they change enough that you can detect change when it actually is present. So there's a lot of, it's not an easy task to figure out what exactly is the right set of items. And that's the task that we are currently undergoing. But basically, the more difficult stuff is on top. Shout out to the vegans and people who are joining, like who are like interacting with social groups, the pro-environmental groups, and then down at the bottom, I think the easiest one that stayed was washing your clothes on cold. Simple thing, it's pro-environmental, it reduces energy use, all you have to do is turn the knob. And so this is like a slightly less stressful version of that lovely graph. We see a pretty good distribution. There's still a little bit of redundancy, and the gaps are, a little bit of gaps as well, especially, kind of over in the high levels of pro-environmental behavior. So you're going to see those gaps come up. But first, let's talk about constructability, because if this doesn't actually, we have to show this is, on the face of it, yeah, okay, most of these measures are pretty clearly pro-environmental or not, but can we show they are a valid measure? So we take the, we ask environmental identification, like do you identify as an environmentalist? We have a couple other measures as well, and you see some of the results. And we find that, environmental identity strongly predicts the REBL score. And it's not the only thing. I think in this one it covers about, I think the R squared is around like 50%, which is pretty good. With the reduced scale, so we went from the 89 to 24 items, you see it's not performing quite as well. It's still strongly significant, so it is still valid, but you definitely can see that we're getting a little bit more noise. We're not getting as strong of a signal. So that's something that you might be trading off when you go with a smaller scale. And now, because I'm trained as an economist, even though I've been hanging out with psychologists more recently in terms of the literature, but I want to compare the REBL score to a revealed preference measure. And one thing I use a lot in experiments is a donation measure. Economists like people to put their money where their mouth is, and we say, as an outcome variable, we'll give you, you're taking an online survey, 1 out of 50 people, you're going to get a $10 bonus. And now you can choose, like, do you want to donate any of that bonus to an environmental nonprofit? And so we find that the REBL score, even like the lower level of items, strongly predicts the donation in the revealed preference measure. So this is a strong indicator that this is performing as well as this measure that is considered to be, at least by economists, is considered to be like the gold standard of like revealed preferences. Because even, a lot of people are like, well, people lie on surveys, and like, there's probably some exaggerating. I do think most people are not completely lying, and we also have little lie detector aspects of Like some people, they said they're vegan and they also said they eat meat. They said they eat beef in the last week. So like those guys got thrown out. So there's some checks within the survey that you can do, and attention checks and whatnot. But still, even beyond that, we're gonna see some of this. So we see it performing well. And once again, as an economist, I have to give you one regression table at least. So we see these two are just looking at, this is the donation measure, atopic regression. And we see that the REBL score, both the 89 item 1 and the 24 item 1 is strongly significant, predicting this donation. And then we throw in some demographic variables to see if that changes things. It only reduces it a little bit. And then to really see if, like, well, why don't we just measure attitudes, and why don't we just measure these other things? Is there any benefit to measuring reported behavior? Does that give us any more information about what people are actually doing versus about how they think? So we throw in environmental identification. We throw in, like, do you think that behavior is, like, there's any point in even trying to be pro-environmental? Do you enjoy being pro-environmental? We throw in all these other additional measures, and we still see that the REBL score is telling us something additional about behavior, at least when it comes to comparing it to the donation measure. And the other thing about these different measures is, like, this always happens with the donation measure. I tell people you get $10 and you can split it any way you want, and people are always like 0, 5, or 10. Like it's strange, but I've like tried to design the question in so many different ways, and it's always like this. They're like 50-50 or 0, all or nothing, and then you have some variation. But this is not a very good, like, that doesn't look like a normal distribution to me. Like, you can do a Tobit analysis, your centered regression to deal with these like points, but it's still not great. Whereas like the REBL score is a really nice normal distribution. This is with the 89 items, and then this is with the 24 items. And if you bin it differently, you can make the gaps go away, but it does show that there's like, okay, so we're not getting as much precision. We're losing some precision on the end over here, and some other gaps. So that's the cost of reducing your items. So basically this, all of this tells me that this is we're on the right track for developing a measure that is going to be extremely valuable in environmental research. And it performs well in, statistically, it's much more valid as a measurement. It's not exactly like a probe that I can insert into your brain, but it's a lot easier to use on an online study or any type of survey. And it also, just to go through a couple others. Well, I don't know, basically, I think I'm almost out of time, but what I hope for this project and for this scale is that we can start building knowledge more rigorously, because it's funny. I think I've been reading the literature, and I don't know, Tom can back me up here. Like, we know a lot of things about what drives environmental behavior, but we can't say for sure. It's very difficult to really understand. There's all these controversies, and measures. Some interventions work sometimes, and then they don't work other times. And there's just a lot of noise, and I think that the lack of good measurement is a real inhibitor of the ability for this field to build solid knowledge, to really understand how does this stuff change over time. And in the long run, I'm really interested, I studied evolutionary biology, and that always still drives my thinking. I'm really interested in how does what causes people to become more environmentally friendly over time. I don't think it's just like a one-stop shop where I watched that David Attenborough documentary, and now I'm I'm an environmentalist forever. Although he is pretty wonderful. Instead, I think that it's likely an evolution over time that you might have something that happens at time 1, drives you to be a little bit more pro-environmental. Maybe that is then validated by the people around you, by the social norms around you. That causes you to grow a little bit further on a pro-environmental scale. Maybe something else happens where you hear, oh, well, actually, lithium mining is terrible, and we're destroying the planet in other ways, and maybe that's going to make you step back. Whatever it is, it's this evolutionary process that you need to be able to measure over time in order to understand those different drivers. So hopefully, this REBL score will work out very lovely in all of its dimensions, and then will be picked up and used in a lot of different types of research. Bam. This is more boring stuff about measurement theory, unidimensionality, invariance, validity, basically other types of checks that we're doing to make sure that this is performing well as a measure. And next steps. So hopefully we're going to be resampling these participants next week to get that temporal variance. We're going to run additional tests. There's also, this data is really rich. Like we had 2 wonderful undergraduate theses that were written on this data, but also looking at like person separability. Are we able to tell people apart on these scales? And then I'm really interested in thinking about how to use cross-validation to, like, we have different criteria for what we want to see from this scale. And now we have 1,000 people who've we've asked all these questions. Now, what I'd like to do is, let's pull 25 random items and 200 random people from our data. We run these various tests. Do that, 10,000 times, and see which set of items is going to perform most consistently and with the strongest validity. And then eventually, we're going to use the scale in a bunch of randomized controlled experiments to help move the rest of the science forward. And I think that's all I have.